Welcome back, MEFB 2013 Manufacturing Processes class. Welcome back, guys. Okay, so if you remember the last class, we spoke about metallic, non-metallic. I told you metallic divided into ferrous, non-ferrous, non-metallic divided into organic and inorganic. And during our discussion, we did comparisons between ferrous, non-ferrous, organic, inorganic. Yeah, and then we realized that we have a problem using material in its pure state. Why? Because material in its pure state, just as it has advantages, it comes with disadvantages, and this will contribute to the failure of the material. Therefore, it's not suitable when it comes to application purposes. It's not suitable to use material in its pure state, and that's when we come up with composites. Yeah. So we also, besides that, we also spoke about the stress strain curve. Okay, we spoke about how a stress strain curve will describe the behavior of a material. So you have your elastic limit, your yield point, and then you have your ultimate strength, and finally the breaking point of the material. And also when we spoke about the stress strain curve, we spoke about the three formulas that you can generate from the stress strain curve. So stress equals to force over area, stress equals to strain times elasticity, and strain equals to the elongation of the material. Yeah, so we did some calculations on that, so I hope that you would be able to do those calculations if given in your assignments or whatsoever. Yeah, so the most important criteria, or how do you evaluate your material? You have to evaluate your material based on the engineering properties of the material, like density, tensile strength, compressive strength, ductility, etc., etc. Okay, so now let's look at composites. Yeah, so what are composites? So composites is actually composites are actually a complex solid material composed of two or more materials that on a macroscopic scale forms a useful material. So as I told you, it's not suitable to use material in its pure state, because just as every material has its advantages, it also comes with disadvantages. So in order to overcome this disadvantage, we need to transform, or we need to come up with a composite. What is a composite? It is a complex solid material composed of two or more materials that on a macroscopic scale forms a useful material. So an example, so meaning that you can either mix ferrous with non-ferrous, ferrous with an organic, or ferrous with an inorganic, depending on the suitability to create your composite. And this composite must be able to overcome, it has to have the capability of overcoming the weaknesses that is present in the base material. At the same time, it may impart properties that is not present in both the materials. Yeah, so that's when we come up with a composite. So an example of a composite is a mineral paste composed of monocalcium phosphate monohydrate, tricalcium phosphate, and calcium carbonate, dry mix, to which a sodium phosphate solution is added to form a paste which is surgically implanted into acute bone fractures and hardens within 10 minutes after injection. And this new material eliminates the need for heavy and uncomfortable casts. So why use composites? One can reply in part of follows. So basically, when you use a composite, there has many advantages. Number one is to increase the stiffness, strength, or the dimensional stability of the material. So initially, when it's in its pure state, it may lack stiffness or strength. So now when you come up with a composite, the composite material will be able to overcome the weaknesses of the pure material. So it's now much stiffer, stronger, and more stable in dimensional stability. Number two, to increase toughness. Number three, to increase the heat deflection temperature. Number four, to increase mechanical damping. What's mechanical damping? Mechanical damping is the material does not bounce. Okay, it does not bounce like your car. You need to have mechanical damping in your seat so that when you go on humps, you're not like jumping. Yeah. So all your car comes with all your automotive vehicles, yeah, come with mechanical damping to make sure that there's shock, the vibration is being absorbed and you're not bouncing in the car as you go on bumpy roads. Yeah. To reduce permeability to gases and liquids. Okay, so number 5 is actually the biggest key or the biggest contributor to the whole composite issue. Yeah. So if you see, to reduce permeability to gases and liquids, it also contributes to the toughness and the strength of the material. How? Let's look at this. Yeah. So when you have a material, in its pure state. Okay, so this is a material in its pure state. So if you see, there's only one type of atomic structure that is present in the material, and the atomic structure is random. Yeah. So in between, if you see in between, there's voids or ruang kosong. There's voids or ruang kosong that is present in the material. So these voids or ruang kosong is the only path for a crack to propagate. So now if there is a hard impact on the surface, the impact creates a crack, and the only way a crack can propagate is through ruang kosong or the voids that is present in the material. So once the crack propagates, the material will split, and the crack can propagate easily because there's so much of voids present in the material. However, when you come up with a composite, if you see the composite is very complicated because a composite is made of 2 or more atomic particles bonded together. Yeah, 2 or more atomic structures that are bonded together. So you find that in between the larger atomic structure, there are tinier atoms that are trapped within the structure. And when there is a crack, on the surface, the crack will be, when there is a crack on the surface, the crack will try to propagate. But do you see any spaces for it to propagate? No, because in a composite, it's made of more atomic structures, or combination of 2 or more, or 3 or 4 atomic structures. So all the tiny atoms will get trapped in between each other, and it will close off the ruang kosong, or close off the voids. So in this material, you see there's a lot of voids. But here in this material, there is no voids. So now when the crack tries to propagate, the atoms will fight back. It will reflect back until the crack will die off as a surface crack. The crack dies off as a surface crack. Okay, so the act of the atoms fighting back to prevent the crack propagation increases the toughness of the material, and therefore it increases the strength and the hardness of this material. So that is number 5, yeah, to reduce permeability to gases and liquids, and at the same time it increases the toughness and the strength of the material. Number 6, to modify electrical properties. Okay, it increases electrical resistivity of the material, to reduce cost, to decrease water absorption. Okay, why does it decrease water absorption? Right now in a composite, there is no voids or very minimal voids. So would it be where when a material absorbs water, it will store the water in the voids or the ruang kosong if it's a pure material. But here in a composite, there is not much void, so there's very minimal place for water absorption. So even if it absorbs water, there's no room or very minimal room to store it. So you can safely, bravely say that it will decrease water absorption. Yeah, to decrease thermal expansion. Again, no room for thermal expansion. Do you see the atoms are so tightly packed? There's no room for thermal expansion. Thermal is heat, yeah, kembang atau mengecut. So there's no room for thermal expansion for a composite material. To increase chemical wear and corrosion resistance, to reduce weight, to maintain strength or stiffness of the material, and to improve design flexibility. Okay, so composites are used in the making of aeroplanes, making a lot of materials. Actually, all materials or all products around you are, namely, when you talk about products and it's about and it involves application, that means it's going to be used in a particular application. The product definitely has to be made out of composites. Otherwise, your product will fail. Okay, just because of the fact that every material, just as it has got advantages, it also comes with disadvantages. Okay, so the solution to solving this problem is to come up with a composite. Okay, thank you.